Alright, good morning everyone. Here we are in the last day of March 2020, and your essential question for geometry today is, how can I use secants and tangents to solve circle problems? So we'll start off with a review of a couple of definitions. We said yesterday that a secant was a line that intersected a circle in two places. So in this case, line L is a secant. Well, we're going to be working with tangents as well today, and a tangent is a line that intersects a circle in exactly one place, and we could call this point C right here. So a tangent is a line that intersects a circle in exactly one place. In exactly one place. In this case, this point C right here is called a point of tangency. That is the point at which line B is tangent to circle D. So let's get a rule in your notes that applies to secants and tangents. And if a secant and a tangent intersect at the point of tangency, then the measure of each angle formed is 1/2 the measure of its intercepted arc. And let's get a diagram of that. So the first thing we're going to need is a tangent and a secant intersecting at a point of tangency. So line L here intersects the circle at point A, and then this would be our secant that intersects the circle at point B. And for description purposes, we'll put point C on the circle as well. So what this rule says, or this theorem says, is that if a secant and a tangent intersect at a point of tangency, which they do, point of tangency is point A, then the measure of each angle formed is 1/2 the measure of its intercepted arc. So if we call this angle 1 and we call this angle 2, the measure of angle 1 will be equal to 1/2 the measure of arc AB. So this angle, angle 1, will be 1/2 the measure of this arc AB. The measure of angle 2 will be equal to 1/2 of the measure of arc BCA. So here's your angle 2. It's going to be half the measure of this arc. Keep in mind that in this case, angle 1 plus angle 2, alright, the measure of angle 1 plus the measure of angle 2 is going to be equal to 180. And also keep in mind that the measure of arc AB plus the measure of arc BCA is going to be equal to 360. Okay? Angles 1 and 2 are a linear pair. Arc AB and arc BCA, yellow arc plus green arc, has to equal 360. Alright, so that's the rule, the description, and the diagram. And now we need to apply that to some problems so we can solve triangles. So let's take a look at a couple of these. Find each measure is what we're going to be doing. And let's see, we've got a circle with a tangent, and a secant, point of tangency, we've got point Q, P, R, and S, and arc PR is 148 degrees, and you are asked to find the measure of angle QPR. The measure of angle QPR, well, here's angle QPR. QPR, and just as the rule says, the measure of angle QPR, well, the measure of angle QPR is going to be equal to 1/2 the measure of arc PR, or 148. So now we can just substitute. Okay, the measure of angle QPR is going to be equal to 1/2 of 148. So 1/2 of 148 74 degrees. Okay, so this angle in here, this angle QPR would be 74 degrees. If we wanted to find the angle on the other side of it, put a point T out here. The measure of angle RPT would be equal to 180 minus the 74, because again these two are a linear pair. So the measure of angle RPT would be equal to 106 degrees. Alright, in this next problem we're going to be finding the measure of arc DEF. And here's our circle. There's our tangent, and here's our secant. And we've got a 64-degree angle here. Alright, and they want the measure of arc DEF. So this is arc DEF. Starts at D, it goes through E, and it ends up here at F. So remember what we said earlier, arc DEF and arc FD need to sum 360. So the first thing we can find is the measure of arc FD. So the measure of arc FD is going to be equal to 2 times the 64-degree angle. Alright, so the measure of arc FD is going to be equal to 128 degrees. So this green arc is going to be 128 degrees, which makes the measure of DEF equal to 360 minus 128. So 360 minus 128, that makes arc DEF equal to 232 degrees. Alright, so let's do a few more. In this next problem, we are going to be finding the measure of arc JLK. And here's our circle, our tangent, and our secant. So here's point L. Point J is our point of tangency. Alright, so we need the measure of JLK. So JLK, this major arc, starts at J, goes through L, and ends at K. Alright, so the measure of arc JLK. Remember, the original rule said that this angle in here, this 116, was equal to half of its intercepted arc. Well, in this case, the intercepted arc is JK. So if the angle is equal to half of the intercepted arc, then the intercepted arc is equal to twice the angle. So in this case, the measure of arc JLK would be equal to 2 times the 116. Alright, so the measure of JLK would be equal to 232. This arc is 232 degrees. Alright, we got one more example problem, and then I'm going to give you some practice problems to do on your own. So in this last example, we are going to find the measure of angle RQS if the measure of arc QTS equals 238. There's your given information, and here's what your circle looks like. Point of tangency is point R right here. No, I'm sorry, point Q. Here's your tangent going through point R, and your secant travels through point S, and point T is on the line right here. So let's apply this given information. We need RQS. Alright, so we're looking for this angle, RQS. We need this angle right in here. And we know from our rule that that angle is equal to half of its intercepted arc. And its intercepted arc is this green one. But it looks like we are given the measure of QTS. We're given the measure of the blue arc. This is the blue arc that goes around the back. And its measure is 238 degrees. So let's find the measure of arc QS first. Well, the measure of arc QS is going to be equal to the 238. Oh, I'm sorry, let's do this. Green arc and blue arc need to sum 360. So the green arc QS is going to be equal to 360 minus blue arc, which is 238. So the measure of arc QS is going to be equal to 360 minus 238. Which is 122 degrees. Alright, so arc QS is 122 degrees, which means the measure of angle RQS is going to be equal to 1/2 of its intercepted arc, so half of 122. So the measure of RQS is going to be equal to 61 degrees. And that's this yellow angle right in here. Alright, so that concludes the theorem, the rule, the diagram of the rule, the math behind the rule that we're working with today. I've given you some example problems, and what I'm going to do now is I'm going to give you 4 practice problems to do. Once you've completed those 4 practice problems and you're very comfortable with your answers, then I want you to log into Focus and take care of today's assignment. So let's kind of write this down. Your assignment for today to go back through your notes, highlight your notes. So let's revisit the notes. Highlight. and mark up. Answer the focus question. Or the essential question. And then complete today's practice problems. Double, triple check all your work, and then I want you to complete the focus assignment. Okay, so here are your 4 practice problems for today. We're going to call these practice problems. And number 1. We want the measure of angle QPS. And here's our circle. Here's our tangent. Here's our secant through point S, and here's 250 degrees. Here's your practice problem number 2. We're going to find the measure of arc BCD. Point D is your point of tangency. We have 108 degrees, and we got points A, D, B, and C. Practice problem number 3. And find the measure of angle 2. For this circle, point of tangency is B. Here's your angle 2. And an arc of 146. And practice problem number 4. The measure of arc PM given the following circle. And 72 degrees. Alright, so that concludes your work for today. Again, I would like you to revisit your notes. Highlight what's important. I want you to answer the essential question. Then I need you to complete the 4 problems, the 4 practice problems that I just added to the bottom of this video. And then I need you to go on focus and complete today's online assignment. I'll talk to you tomorrow.